Hi there, welcome back to my channel. In this video, I'll take you through linear approximation. In our previous lessons, we dealt with tangent planes, finding the equations of tangent planes. So we continue from this section by going through linear approximation. So if this is the first time you've been on this channel, kindly subscribe to support and watch this video to the end. So we know that tangent planes, what they do is they tend to approximate. Okay, they tend to approximate the surface near a point. The surface near a point. So if you want to find the tangent plane at any particular point, it means that you are trying to find the surface, okay, around that particular point, the surface around that particular point. So through tangent planes, we can find the linear approximation of a function at that particular point, right? That is, we can approximate this functional value at this point. That is the concept of linear approximation. So linear approximation takes the form of what? A tangent plane. But in this case, we are not finding what? The equation of a tangent, but rather is an approximation. Okay. So generally, linear approximation is giving us the linear approximation at a particular point xy. Okay, is giving us f of x naught y naught. Okay, that's the functional value of what? The point, then plus the partial derivatives of x at the same point. Okay, partial derivatives of the partial derivatives of what? Of this function at the same point multiplied by x minus x naught, then plus the partial derivative with respect to y of the point x naught y naught multiplied by y minus y naught. Okay, so generally this is the formula for finding the linear approximation to every function at a particular point. So you are trying to approximate the surface, okay, surface near that point. So right now, let's see the parameters of this equation. So to find linear approximation at this particular point xy, right? So I have my x naught and y naught, which is what? Negative 4, 3 from the question. So what I need is my fx and what? Fy, right? So what are my fx? So my fx is simply equal to, the function z is the same as f of xy, right? So you can say that z is equal to f of xy because the function taking in x and y what input. So the fx simply becomes the derivative of this with respect to what? X. My y becomes a constant. Okay, so derivative of 3 is 0. Derivative of the x will become what? 2 times x on 16, and this gives us x on 8. Okay, so the functional value at the partial derivative of this function here, so fx of negative 4, 3 then becomes what? I'll only take my what? 4, negative 4, so negative 4 on 8 giving negative half. Then I'll have fy is equal to this one to x to go away because x is a constant. So I'll simply have 2 times y on what? 9, right? So this gives me 2y on 9. So the fy of negative 4, 3 is simply equal to 2 multiplying, what's our y? 3, right? All over 9. 3 goes into this of 1 and go here 3. So I'll simply get 2 out of what? 3. So this is the functional value at what? Negative 4, 3. So for us to approximate this function here at this, I'll simply have to find the functional value at this point as well. Okay, the functional value at this point as well. So what is f of negative 4, 3? F of negative 4, 3 is simply equal to 3 plus negative 4 squared all over 16 plus my y is what? 3, so I'll have 3 squared on 9, then that's all right. So I'll have 3, this is 16 on 16, I'll have 1, then 9 on 9 also have 1, so I'll get 5. So my functional value is 5. So the approximation here is simply what? The functional value, which is 5. So L of what? Negative 4, 3 will be equal to, so sorry, the linear approximation is just a function. Okay, it's L of what? Xy, not x naught, right? So let's see. So linear approximation generally is going to give us f of x naught y naught, which is our 5, right? So 5 plus fx of what? X naught y naught. That is the partial derivative at that particular point. We had it to be negative half. So minus half multiplying x minus x naught. The x naught is negative 4. So x plus 4. Then I also have plus 2 on 3, which is the fy at this point. Then multiplying y minus what? 3. Okay. So this lxy, linear approximation of the function, can be given as 5 minus 1 out of 2 x plus 4 plus 2 over 3 y minus 3. Okay. So now we have approximated our function at the point negative 4, 3, and that is what we are getting here at the point negative 4, 3. This is the approximation. So always, in summary, to find the linear approximation, find the partial derivatives at the particular what point given. Then you multiply it by what? X minus x naught, that is the change in x, y minus y naught, the change in y. Okay. Then after, you add it to the what actual functional value to give us our approximated what function. So thank you for being with me in this video, and don't forget to subscribe, like, and share.